You should watch this video before uploading your code to the cloud. Hello everyone and welcome back. In this video, we'll be covering different kinds of Git files you can use in your project, and then we will push code up into the cloud on GitHub. So let's get started. So the first file we'll talk about is something called the .gitignore. And this file is used to tell Git to not track these certain specific files or directories. This is very useful if you have something like a .env file, API keys, or anything you don't want published to the cloud where people can access them. Even if your code on the cloud is private, it's still not a good idea to push these kinds of things. Let's say we had a .env file with some kind of API key that we don't want other people accessing. We can see in VS Code right now it is considered untracked, and if we go ahead and pull up the terminal, we can switch into the git demo folder since I am a directory above it, and we can type git status, and we can see that it's currently an untracked file. We want to avoid accidentally adding this, so in order to do that, we can go over here and create a .gitignore file. Make sure it's in the git demo directory. Go into terminal and type git status again. We can see now there's two files that are untracked. We will go ahead and add this one so it can apply to everything in the future. And whoever pulls our code can also get the same gitignore, so they won't accidentally push the same kinds of files as well. But here we'll type .env because that is the file we want to ignore. And we can see on the right here, this .env has now been grayed out a little bit, meaning that Git is not tracking this. If we come back into the terminal and type git status again, we can see it has been removed from the untracked file section. Let's say you had more than one env file, and you can come here and just type dev.env. We can use a star for pattern matching, which will mean any character .env, we're going to ignore those files. We can see it updated here over in the file tree that the dev.env file and the .env file are both being ignored with this one pattern. If we had it to where our secrets are in some kind of secrets directory, we can type secrets / ignore anything in the directory of secrets. And we can see on the right side, this entire folder has been grayed out. If we wanted to keep this folder here but ignore everything inside the directory, Git does not automatically keep these folders by default. We'll go ahead and change back to star.env, and we can see that they have been grayed out over here in the folder, but the folder name has not been grayed out. And you would think that means it's still tracking the folder, but it's actually not. Git does not automatically track folders for you. It's not even considered an untracked. In order to have this folder here, but with nothing inside of it in Git, you have to add a file called .gitkeep. And when you do this, it will add this folder to Git, regardless if it has stuff in it or not. So if I do git status again, we can see this folder has been considered an untracked file now. So even if we didn't have these other items in here, and we type git status again, we can see it still is here as an untracked file. If we did git add the secrets folder, we can see it has been added. But if we add an env file in here with our secret, we can see it's still grayed out, meaning that Git is not tracking it even though we're tracking this folder. Depending on what kind of code base you're creating, there's different gitignores that are designed specifically towards it. Like if you're doing Python, there are Python specific gitignore files that you can find online. Same thing with JavaScript, Rust, anything else out there. But let's say that you accidentally added your .env file when you shouldn't have. You can type git rm -- cached secrets / .env. And this removes it from being tracked by Git. And we can see over here, it now has a U as untracked. Now, if you have worked on Git projects that are both on Mac and Windows or Linux, there's a very common issue that happens where line endings are not the same. The way that Windows handles line endings is not the same as the way Mac and Linux do. In order to fix this, we can create a file called gitatributes. And here we can specify how we want to handle line endings in our files. A very common one you will see is a *text = auto. And this will say that any text files will have an automatic ending being applied. There are 3 different kinds of line ending types. One is LF, which is just line feed, and that just has an ending of a new line character. And this is used by most Unix systems and Linux and Mac. Then we have CRLF, which is carriage return line feed, and this is used by Windows. And that will have the line endings of /r/in. You won't see these line endings directly since they are rendered invisible, but they can cause problems. Then you have just CR, which is just the /r for a carriage return. Mainly old Mac OS systems use this, but it's not very common today. So an example of this is if one person uses Windows, which uses CRLF, and another person uses Mac or Linux, which is LF, each commit can just cause extra changes that don't need to be there. Many compilers, interpreters, and scripts expect these LF endings, especially Docker builds, Python on Unix, and Bash. A lot of them will break on CRLF endings. The .gitAttributes file helps control how Git normalizes and checks out line endings. So Git stores files in the repo with LF by default, but when Windows checks out, it converts it to CRLF automatically. And when a Mac or Linux operating system checks out the repo, it converts it to LF. Normalizing how this stuff happens helps reduce these diffs. We can say for all shell scripts, we want the end of line to be LF instead of CRLF. We want to force this, so whenever we create a new shell script, it will automatically be LF, so there's not going to be any issues running this on different operating systems. If we were having Windows-specific scripts we want to make sure it's CRLF. So in this case, a .batch file will have the line ending of CRLF. Another very common one we'll see is we want all the PNG files to be treated as binary. This prevents Git from altering line endings or differing them as text. Here are some examples of different line endings. An advanced use of this .gitAttributes is we can actually make GitHub classify a file as a specific language. So if you wanted all SCSS files to be classified as CSS files, we can do this kind of syntax right here. If you want to force our files to have a UTF-8 encoding, we can do this kind of syntax right here. If we wanted to mark an entire folder as binary, we can do our folder name followed by 2 asterisks and then binary. The next file we'll go over is the gitconfig. So Git uses a layered configuration system to define how it behaves. It reads configuration from multiple locations and merges them together based on the priority. There are 3 different configuration levels. There is the system level, which applies to every user on the same machine. It's used for shared environments, stored in Git's installation directory, and rarely modified manually. Then we have the global level, which applies to your user account. This is the most commonly edited configuration, and it's stored in your home directory. Then we have the local level, which only applies to a specific repository, and is stored in your folder name .gitconfig, right here. This overrides all other configuration levels. If you want to see a list of all the merged configuration, you can do gitconfig --list. If you want to see all the configuration that's in your global gitconfig, you can do --global. Same thing with the system and the local. If you wanted to edit the global Git configuration, you can do gitconfig --global --edit. If you want to set a specific value inside Git, we can do gitconfig and then specify at what level you want this. So I'm doing global user.name, and then you would pass your username. And for this, I'm just going to do an example of example user. For you, you would put whatever your username would be, let's say on GitHub. And then we also want to set the email for our user and just have an example email here. If I were to go ahead and do this git config without setting the global flag while having this config file open inside of our repo, it adds this field here of the name for the user in this repo. If we do the same thing for the email, we can see the email was added here too. This will basically define who you are in the Git history. There are some other configuration here and many more kinds of configuration you can add, but I won't cover that in this video. But one thing you can add here is in this core, you can add auto CRLF to true to force it to be just like Windows, or change it to input to be like Mac or Linux. So now that we have this set up, I'm going to go ahead and add both of these to the repo and commit it. So now that we have some local changes, let's go ahead and push it to GitHub. So here on GitHub, go ahead and create an account. And once you log into here, we're going to go ahead and create new and then create some kind of repository name. So for this one, I'm going to do git demo, since this is available under my account. You can add a description if you want to. Since we already have an existing repo, we are not going to add a readme, gitignore, or license to avoid any kind of conflict. but you can make this public or private, whichever one you prefer. And we can see it does have a predefined gitignore here. So you can come in here and search something, let's say like Python, if you want a Python specific gitignore. You can see different options of what they have here for your project. If you don't see your option here, you can just go online and find it. But now that we have this, we're going to go ahead and create repository. And we can see here it gives us a few options. The option we're going to do is this one down here, since we already have it set up locally. And we did not add anything in the cloud when we were creating this repository. So you can basically just go here and copy all the commands. So here we'll go ahead and paste that first command in there. And we can see as we do this in this .gitconfig, it did add this remote origin here, showing the destination of the Git repository. Then we'll go ahead and get the next command. And then the last command. And we can see it officially pushed it up into what we call origin main. And the origin just refers to the remote branch. So in this case, it's the origin on GitHub. If we head back up into the browser and go ahead and refresh the page. So you can see it now has all the code that we had in VS Code, all uploaded into the cloud. It even has the stuff we had in the README displaying here. And if we go ahead and open the secrets file, there's nothing in here but that .gitkeep we added from VS Code. One thing to note, if you did want to switch it between a public and a private repository, you can come up here into settings, then go ahead and scroll all the way down. Then you have a change repository visibility, and you can change it here to private and vice versa. There's no secrets in here. If you're working with someone else and you want to see if there's any changes you need to get, you can do git fetch. And this will check and tell you if there are any changes. If no changes, there's no output. But if you need to go ahead and pull those changes, you can do git pull. And that will pull all the changes down into your local repository. If you have changes that you have not yet committed, it will throw an error. And for that, you could do a git stash to go ahead and stash your changes, and then do a git pull, and then do a git stash pop to go ahead and get those changes back. There are some more advanced commands like merging and rebasing we'll talk about in another video. Thank you so much for watching. If you found this video helpful, leave a thumbs up, subscribe, and I'll see you in the next one.